The question says that a spherical conductor of radius 12 cm has a charge of 1.6 into 10 to the power minus 7 coulomb distributed uniformly on its surface. What is the electric field? Inside the sphere, just outside the sphere, and at the point 18 cm from the center of the sphere. So here in this question, a sphere is given which is a conductor, and it has a radius of 12 cm and it has a charge of 1.6 into 10 to the power minus 7 coulomb distributed over its surface. Now we have to find out electric field in three different areas. The first is inside the sphere, and the second is just outside the sphere, and third is at a point 18 cm away from the center of the sphere. Now we know for a property of conductor that any excess charge inside the conductor resides on the surface of the conductor. No net charge is present inside the conductor. So for the first part of the question that said that what is the electric field inside the sphere, we can apply Gauss law inside the sphere. Assuming that there is a Gaussian surface inside the sphere, there would be no charge inside the Gaussian surface. Thus, flux would be zero because there would be no charge inside the Gaussian surface. Thus, electric field would be zero. So, for the answer of first part of the question, that what is the electric field inside the sphere, the electric field inside the sphere is going to be zero. The second part of the question says that what is the electric field just outside the sphere. So, for this, we can assume that for a point outside the conductor of radius 0.12 meter, we can consider all the charges Q to be present at the center. Now by Gauss law, we can say that phi net or the flux net through the Gaussian surface would be equal to Q enclosed divided by epsilon naught. Now Q enclosed is the charge enclosed by the Gaussian surface. Now flux is defined as the dot product of electric field and the area. Now area of the sphere, surface area of the sphere would be equal to 4 pi r square, and E is the electric field. Now here we are assuming the whole sphere to be the Gaussian surface. So the charge on the sphere would be Q enclosed, and area would be 4 pi r square because we are assuming the surface sphere as the Gaussian surface. Now E would be equal to 1 by 4 pi epsilon naught multiplied by Q by r square, where r is the radius of the sphere. While calculating, we will come to the conclusion that electric field just outside the sphere would be equal to 10 to the power 5 Newton per coulomb. Now the third question said that what is the electric field at point 18 cm from the center of the sphere. Now in this case, we can assume that entire charge is concentrated at the center, and thus we can take Gaussian surface to be a sphere of radius 18 cm, and thus like previously we can calculate electric field like using this formula, and we will come to the conclusion that electric field is 4.4 into 10 to the power 4 Newton per coulomb. Now in this question, one of the most important thing that we applied as a property of conductor was the net charge on the conductor resides on the surface of the conductor, not inside the volume. Thank you.